these are the official notes for recurrence relations. I would always start when I teach this by sort of describing what a sequence is, and a sequence can be defined by a formula for the nth term, so you can work out any value on the sequence given where it is in the sequence essentially, and B, a recurrence relation and initial term, which we are going to be doing a lot in this topic. So each number in a sequence is called a term. So you see me refer to what is the fifth term, sixth term, seventh term, etc. And how would I denote that? Well, I would denote it with this sort of subscript numbers to label the terms, i.e. U1, U2, U3, U4. So U1 would be first term, U2 would be second term, etc. U7 would be seventh term, U10, 10th term, etc. So the number just tells you which term in the sequence it is. So U1 will be your first term on a new sequence. So let's look at an example where you're finding out what's in a sequence. So first, find the first three terms of the following sequences. UN equals 4n. So let's look at this. If I want the first term, U1, it'll be 4 times 1, which is 4. If I want the second term, it'll be 4 times 2, which is 8. If I want the third term, it'll be 4 times 3, which is 12. So essentially you're talking about the 4 times table there. Alright. For B, UN equals 3n plus 2. If I want the first term, U1, I substitute 1 in. 3 times 1 plus 2, which is 5. If I want U2, U2 equals 3 times 2 plus 2, and that equals 8. U3 equals 3 times 3 plus 2, 11. And that's essentially what's happening in these sequences. Next one, C, UN equals 2n squared, subtract n. So in this example, you want to do UN equals 2 times 1 squared, take away 1 because it's U1 you're finding. U2, substitute 2 in, and U3, substitute 3 in. Getting the answers 1, 6, and 15. Now notice that A and B are going up by the same number every time. They're going up by 4 in this case and 3 in this case. That means that they're linear sequence because they're going up in the same number each time. C, it's going up 5, then it's going up 9. So there's a difference there. So that's not a linear sequence because it contains a square term. So this is sort of sequences. Okay, so let's look at recurrence relation type examples now. So a recurrence relation is a rule which defines each term of a sequence using the previous terms. So in these examples, you're always going to be using your last value. So whatever value you had previously is important to your next value. So given the first term of a sequence, which is your initial value that you've been given, and the formula to calculate the next term, we can work out all the terms in a sequence. And it's giving you this kind of number line here. So you've got UN, and then you can find the next term, which is UN plus 1, the next term UN plus 2, the next term UN plus 3. But also, depending on the value of n you've got, you could also find the previous term, which would be UN minus 1. And then the term before would be UN minus 2, and then UN minus 3. So it all depends on what value you're starting with here. So let's think about how that's defined. So UN plus 1, that is the next term in your sequence, is equal to UN, which is the sort of term you've got now, or the last term you had in the sequence, plus whatever value they ask you to add on or subtract, and then it gives you U1 equals 3, so this is your starting point. Now usually you would see U0 or U0 as your starting point, but sometimes they might give you U1, sometimes they might give you U2, so they'll give you a value to start it. It might not be U0, it might be U1, but they're still giving you a value to begin, so that's all you need to worry about. Alright, so let's look at an example then. So example 1, write down the first 4 terms in the sequence. UN plus 1 equals 2 UN minus 1, given that U1 equals 2. So what they're going to do right away is they're going to say U1 equals 2. So that's the very first term in this sequence. So I'm then going to find my second term. So what I'll do is I'll substitute this term, U1, into this part here, UN. So it's going to be 2 times 2, subtract 1. 4 take away 1 gives you 3. So that's U2. Now the important thing about a recurrence relation is this U2 value is important for my U3 value. So what you do is your recurrence relation un plus 1 equals 2un minus 1. You then substitute 3 in for un because un is my current value. So 2 times 3 subtract 1 is 5. So u3 is 5. Then I've got to substitute u3 into the recurrence relation, and that will get me the fourth term in the sequence. 2 times 5 is 10, subtract 1 is 9. So there, 2, 3, 5 and 9, there I have the four sequences that begin, the four terms, that begin this sequence. Now, what you did last week was you looked at how to use your calculator to do this. So what you would do is, you would hit 2 equals, clear your screen, okay, you would then write 2 times answer, subtract 1. Once you've done that, you push equals, you would get 3. You could push equals again, get 5. And you could push equals again, get 9. So I'll just go over that again. When you're doing these, you can type in the initial value, the first value you've got, in this case it's 2. Push that in, hit equals, clear your screen, then type in the recurrence relation you've got. 2 times your answer, subtract 1. And once you do that, you can type it in each time. You can just push equals each time and it will sort it for you, instead of having to type all of this in manually. Okay? But this is just showing you what's happening in a recurrence relation. I'm going to do a second example now. The second example, a sequence is defined by the recurrence relation un plus 1 equals 0.5 un plus 2, where the initial value u0 is 10. So sometimes they'll give you u1, u2, u3 to begin. This time you've been given u0. This is probably the most common type you'll see. So calculate u1, u2 and u3. So if I want u1, I'm going to need to substitute u0 for this part. So I'm going to need to put in u0. So 0.5 times 10 plus 2. Because my u0 value is 10, I substitute in 10 into my recurrence relation. 0.5 times 10 is 5, plus 2 is 7. Okay, now again, what you could do is you could type in 10 equals, clear your screen, 0.5 times answer plus 2. And then when you do that, it will give you 7. You push equals again, it gives you 5.5. You push equals again, it gives you 4.75. But what the actual calculations that your calculator is doing there is, for u1, it's doing 0.5 times 10 plus 2. For u2, it's doing 0.5 times 7, which was your u1 value, plus 2, which is 5.5. And for u3, it's doing 0.5 times the 5.5 plus 2. So the formula is staying the same, but the only thing you're doing is you're substituting in the previous term each time. So u0 is going in here, u1 is going in here, u2 is going in here, and that gives you the four values you need: u0, u1, u2, and u3. There is a practice example in the Teams page now. You can try them out and see how you get on. I'll post solutions and maybe do a video later on just talking you through a couple of the examples. Hopefully this video has helped you. This is sort of beginning of the topic. You will get used to seeing this type of form more and more as the week goes on. Hopefully this is okay. Let me know if you've got any questions.